This video is about harmful algal blooms and their effects in coastal seas of Northern Europe. I'm Bengt Karlsson. I'm one of the members of the ICES IOC working group on harmful algal bloom dynamics. So I'm presenting the result not only by myself, but by colleagues around Northern Europe. So the area in question, that's actually from the North Sea, the Norwegian Sea, the Barents Sea, and the Baltic Sea. And the major types of harmful algae in these areas are phycotoxin producing algae. And phycotoxins, they accumulate in filter feeders such as blue mussels that feed on phytoplankton in general, and they eat some of the harmful algae. And then we have fish-killing algae and cyanobacteria. There are other types of harmful algae, but these are the main ones. If you want to know more about this, you can read two publications. I'm the first author on one in harmful algae, published in spring 2021. And another one is first author Gustav Hallegraaff. And both of them could be of interest to you. So, what types of harmful algae do we have in some more detail? In the Baltic Sea, the major problem are cyanobacteria that produce cyanotoxins, but they also cause problems because they end up on beaches and foul beaches and so on. In the Kattegat and Skagerrak, we have a type of fish-killing algae that cause problems for fish farmers, mainly in Denmark. There are other types of fish-killing algae that I will go into more detail later. And then we have the phycotoxin producers. Alexandrium produces paralytic shellfish toxins. Dinoflagellate produces diuretic shellfish toxins. And then we have a diatom, azidinium, that produces amnesic shellfish toxins, and these are the main ones. Harmful algal blooms are not new to this area. The first observations of cyanobacteria from the Baltic Sea is actually from 1854, when a school teacher looked under an early microscope. Then we have records of diuretic shellfish poisoning in Sognefjorden in Norway from 1870. And for paralytic shellfish poisoning, there were 2 deaths related to mussels from Oslofjorden in Norway in 1901. And from the Belgian coast, there was a PSP event in 1938. And the fish mortalities due to harmful algae have been recorded since 1966. So the harmful events are not new, but they are observed more frequently. Moving into the phycotoxin producing algae. They of course cause problems for the the mussel farmers. So here's an example of a mussel farm in Sweden. And dinoflagellate, there are a few species of them. They cause problems along the Atlantic coast of Europe, all the way from the North Sea to the Barents Sea. Moving on to paralytic shellfish toxins, they are produced mainly by a genus called Alexandrium, and they regularly give problems along the Norwegian west coast and occasionally along the west coast of Sweden and Denmark and along the North Sea coast. Azidinium, that's a small dinoflagellate genus. It's not really a major problem in our area, and that's fortunate. But we have had concentrations above the regulatory level in Sweden and Norway a few times. Moving on to this diatom, Zudunicia, that causes produces amnesic shellfish toxins. they are actually really not a problem in Northern Europe, at least not in our area. In the British Isles, they have been a problem. Then we move on to the fish-killing algae. And these algae, they affect the gills of fish. And wild fish, they can swim away. But farm fish, they essentially die. And we have a few different genera that cause problems: Pseudochatonella, Carenia, Chrysochromalina, and Primnesium. The biggest problem had actually been with the Chrysochromalina and Primnesium. In 1988, a long time ago, there was a major bloom in the Kattegat and the Skagerrak that actually disrupted the marine ecosystem, with fish dying, macroalgae dying, and lots of effects on the ecosystem. This species, Primnesium polylepis, haven't been blooming in such abundances after that. But their relative, Chrysochromalina ledbetteri, have bloomed in 91 and 2019. And the bloom in 2019 in northern Norway actually caused major losses of farmed fish. Then we move on to the cyanobacteria, and this is essentially a problem for the Baltic Sea. Although in some years the cyanobacteria are transported through the sounds into the Kattegat and the Skagerrak. And these are nitrogen fixers. So in the brackish water of the Baltic Sea, they can outcompete other algae when there is still phosphate in the water, because they have this capability to fix nitrogen. And they cause problems by fouling beaches, and some of the species are also toxic, like Nodularia spumigena that produces nodularium. And the blooms of cyanobacteria can be quite spectacular. Here's an example from 2015 in the Baltic proper. Phaeocystis is a haptophyte genus. When it blooms, it forms gelatinous colonies, and in the end, the end result is foam that may end up on beaches, for example, along the southern North Sea coast. And foam can be several meters high, and it's actually a risk for swimmers. It has also been shown to be toxic to cod larvae. There are also blooms of Phaeocystis in the Barents Sea in northern Norway. In that area, it's not considered a problem. We do have other types of blooms that are not really harmful, but they cause a lot of interest from media and the public. For example, we have blooms of Noctiluca scintillans. That's a heterotrophic flagellate that actually eats phytoplankton. They feed on phytoplankton, and they have this brick red water in daytime and strong bioluminescence at night. So there have been some spectacular blooms, for example, in Denmark and in Sweden recently. Another bloom that is a bit spectacular are blooms of coccolithophorids. And they have these calcium carbonate plates that reflect the water and results in turquoise sea. They do cause a bit of a problem for some fish. They have problems finding their prey in the turbid water. Another spectacular bloom occurred. This was in Denmark a few years ago, when a green dinoflagellate bloomed with high biomass and really greenish water. So this was an example from Denmark. Looking at some of the future perspectives of harmful algae in Northern Europe, we do see an increase in the use of coastal resources like aquaculture, fisheries, tourism, leisure activities, and so on. There's also climate change that results in a longer growth season, changed biogeography, and so on. It's quite likely that we will have new types of harmful algal blooms in this area. Some other types might disappear or decrease. But in general, harmful algal bloom events are likely to be observed more frequently. And also the costs of harmful algal blooms will increase. And we think the interest in early warning and detection of harmful algae will increase as well. Thank you for your interest.